Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. In this episode, we talk about Spring with Laurentiu Spilca. Laurentiu has around 11 years of experience as a Java developer, a public speaker, and trainer. He is a published author with titles such as Spring Security in Action and is currently working on a new book, Spring Quickly. Laurentiu provides his training courses to all sizes of businesses, including some large blue-chip companies and some SMEs. He also teaches students at the University of Bucharest. As if it wasn't enough, he also speaks at conferences around the globe and leads a global Java community. Laurentiu also claims to play guitar and piano, to scuba dive, and to ride motorbikes in his spare time. And I don't know about you, but I'm not convinced he's got any spare time. So, welcome to The Cynical Developer, Laurentiu.
Thank you very much. Thank you for welcoming me to your podcast.
Yeah, it's not a problem. I think it's a hot topic, Java versus .NET, but we're not here to discuss that. But we have got a Java developer and a .NET developer that are going to talk civilly about Java. It may be a first for the internet, so this could blow up and go viral, but we'll see what happens.
Sure.
So we're here to talk not necessarily about Java itself, but about a technology called Spring. So could you give us like a 10,000-foot overview of what Spring is?
Yeah, sure. So Spring is one of the most important frameworks we have nowadays in the Java ecosystem. It's actually an application development framework, and we use it to make our apps easier to develop and easier to maintain through things that it offers us out of the box. It started about 15 years ago, and it was already competing what we were calling Java EE or at that time, and now we are actually calling it Jakarta EE. But it very, very fast took advantage, and now it's basically one of the most important frameworks that we actually use. So it's a must learn for any Java developer from my point of view. Spring allows you implement easier your applications, secure them faster, make them faster in general. So it's a very important ecosystem. It's basically named a framework. You say Spring Framework, but it's basically not only a framework, it's a framework of frameworks at the moment. So it's an entire ecosystem of crunchy implementations, capabilities that you can bring out of the box into your Java app and use it to implement things faster and very, very reliable.
Okay. So one thing that I've seen over the years, and I've been approached by recruiters and by companies asking if I was a Spring developer, and a few other people that I know as well have often wondered if Spring was a fork of Java. And you talked there about it was Java E and then it was something else. And I guess that naming change came around when Java was bought out. But it's not a fork of Java. It's not a standalone language itself, but it's libraries that enhance vanilla Java.
Yeah, it's basically a set of capabilities that is designed in such a way in which it controls your application, and that's what we actually call inversion of control. So when you implement something with Spring, when you actually implement something with a normal, say, library, you actually make use of that library from your application. But when you implement something with Spring, you actually configure your application to be used by Spring, to be controlled by Spring, and that's what we call inversion of control. So you allow Spring, the framework, the dependency, to control your application instead of controlling your dependency. You allow the dependency control your implementation. So that's a very big difference between how a framework works and how a library works in terms of bringing some new capability to your application. And yes, it's not a fork of Java. Nowadays, we discuss about distributions of Java. In 2017, I remember I was at the last Java 1 conference. Now it's called Oracle Code 1. And at that point, Java 9 was released, and they announced the fact that, first of all, they will release Java, a new Java version at each 6 months. And the second important thing was that they will have different distributions of Java, and there will not be only one distribution of Java. Now everyone can take their own open source distribution, but Spring is not a Java distribution. Spring actually uses Java as a language and implements a lot of nice features that you have in your application, no matter of your business implementation. So no matter your business logic, if you are a ride-sharing app or you are a banking app, you have functionalities, you have capabilities like logging, security, transactionability, and so on that you need to use. And those, instead of having to rewrite them, instead of having to reinvent the wheel, you just use Spring, which is used by so many developers around the world already. It's tested. The functionalities are reliable, and we trust them. And instead of having to implement them yourself, you use the framework and you bring those capabilities into your application, those capabilities that are known by and used by an entire community, a very big community of developers. So that's how things work. So Spring is a set of capabilities you bring into your application by allowing the framework to control your app. The difference between the framework and having a library, a simple dependency. And by that, you use a set of capabilities that is trusted by a very, very strong community.
Sure. So when you're building an application using Spring, is the syntax that you write the same as writing normal Java?
You can use Java. So that's one of the things. It started as a simple Java framework, but take into considerations that when we discuss about Java, we actually, Java is, for me at least, equivalent to saying the JVM, which is the Java Virtual Machine. So the Java ecosystem, which started as being Java in 1995, is now not only a language, but it's an entire ecosystem that has a lot of other languages which can be turned into the same bytecode that you turn Java apps, Java sources, like Scala, for example, like Kotlin, which is very hot nowadays, the language invented by JetBrains, like Groovy, and so on and so forth. So the whole idea is that, for example, when you implement an application with Spring today, you can decide to use, for example, Kotlin instead of using Java for its main implementation, because Kotlin is a source code that you in the end turn into the same bytecode that the JVM interprets. And that you can even make it, it's compatible with Java, so you can even mix it with Java, but I don't recommend that. I usually like my apps have one language and use one language, especially if today you use, for example, microservices. It's in the end the architecture quality of being polyglottic. So instead of having an application with multiple languages, I decide of having maybe multiple applications, each of them using one language. But the idea is that you can, for example, implement Spring applications with Kotlin if you'd like, or with Groovy if you'd like. So when we say Java, it's the ecosystem or is the language, but you can at the same time say, I would like to implement a Spring application by using Kotlin as a language, which is part of the Java ecosystem, something like that.
Sure. Yeah. So you sort of you answered a question that I had there, which was if we could use Spring with Kotlin, or if it was comparable to it, because I didn't really understand what Spring was, and I'm quite a bit of a JetBrains fanboy. I use Rider and DataGrip and all their other stuff. So there is, as you say, a bit of a hotness around Kotlin at the moment. So it's interesting that you can now take what started off as a framework for Java and use it with all these other languages, which essentially, as you say, compile down to the same bytecode that is required by the JVM.
Fortunately, I was lucky enough a couple of years ago to be able to write an application in production that used Kotlin with Spring, and I can say it was fun. So I'm not necessarily a fan of Kotlin. I like Java; it is my language. But I, as a as a development consultant in the Java ecosystem, I used as well Scala, for example, or Kotlin, and things related to those technologies. And it was quite a good impression on Kotlin. I can't say I would reject the language. It's quite good, and it's known more for its Android capabilities rather from the for the backend implementations. But it's a nice feature.
Yeah, I know some .NET developers that if you'd asked them to write a Java application, they probably would have spat at you, but have jumped on board and they are now Kotlin developers, or it's a tool in their belt. So it is interesting, and maybe it's something that I can find somebody out there who's listening who wants to come and talk to us about Kotlin as well, and fill me in, let me understand what Kotlin is and what it brings to the table. But Spring itself makes some pretty bold statements when you look at the website. It says that it provides fast startup, a fast shutdown, optimized execution, and if this is just short, if it's talking to the same JVM as Java, how is that possible?
To answer you honestly, so when I think about Spring, I don't necessarily think about performance itself. I actually think more about maintainability, because when I use Spring, I use it to bring into my application capabilities that I rather would have to implement them by myself. And there are two things maybe I have to take into consideration when I want to implement any feature by myself, feature that might be supported already by an important framework like Spring, like, or important in community, I would say, rather than the framework itself. The idea is that when you implement something by yourself using a vanilla language, like using vanilla Java, you might first of all make mistakes, and secondly, you might actually, but the same thing would leverage to have a worse performance, worse security, and so on. So when you use a framework like Spring, it is less probable that you will include bugs or vulnerabilities into your application, because you already use capabilities that have been already tested by a very big community. So being supported by such a large community, it also assures you that the framework brings quality in its applications. Because if there were any vulnerabilities or bad performance issues, then the community would have discovered them first, or they discovered them very fast and then they solve the problems. So it's very unlikely that you will bring those into your application. But if you implement something by yourself, then you are the only one knowing that feature, and you are the only one testing that feature. And then you might skip things, and you might include vulnerabilities or bugs into your application that could bring a lack of performance, for example, or lack of maintainability as well.
Sure. So yeah, it says that it provides security as well, and I guess it means that it's more secure than just using vanilla Java. But as you said there, the reason that it's more secure is that Java itself is, here's a programming language, go and write whatever it is you need. Whereas Spring is giving you all the building blocks that you need. And it goes, well, you want to do a certain thing? Well, here's the building block for it. It's already been tested and tried, and we know it's secure because it's been used by millions of people, and it's been written by people that are smarter than you and I, who specialize in those security principles.
Exactly. Yeah.
So it's like it's standing on the shoulders of giants. And it sounds like it's a little bit like what we see in JavaScript with the likes of NPM packages, and in .NET with NuGet, is that there's all these little building blocks that you can go and pull in, and you can just use them out of the box. But with this Spring framework, these are quite big fundamental pieces of an application that you can stick together and don't need to worry about it. So you can actually spend your time, I guess, worrying about the problem that you are trying to solve, rather than which encryption should I be using, how should I be securing this information, and all that sort of stuff that it's necessary and takes up a lot of time. Whereas you could be spending that building the application and fixing or solving the problem.
Yes, exactly.
Okay. If a listener is out there thinking, oh, this Spring stuff sounds pretty good, and they've got an application that they've currently written in, and I keep calling it vanilla Java, but just in plain old Java, whichever distribution that is, are they able to upgrade, for want of a better word, that to Spring, or port it into Spring? Is it an easy process?
That's a very interesting question. I really like it because as a Java consultant, as a development consultant, I've been in this situation a lot of times in the past, more than 10 years, 11 years, whatever. I've consulted more than 20 projects, and some of them, they actually did this. They actually wanted to go from vanilla Java to Spring. And it seems that it might be difficult because sometimes the applications are not clean. And they didn't consider principles that we now know, but 25 years ago they were not there, like the solid principles. But it's not that difficult in the end, and the idea is that it can be done. And the idea is that not only that it can be done, but it's the first thing I would recommend someone to do before, for example, trying to change architecturally their system. So the most difficult situation in which I've been put in those more than 20 projects I've been done consultancy for in the past years is when one of my clients wanted to change their architecture from a monolithic one to microservices, and we know nowadays it's something that's not that. It's quite often encountered nowadays that some companies want to port their solutions from monolith to microservices. But what happens when your monolithic application actually is designed in the vanilla language, like in vanilla Java? And the first thing is, yes, you need to choose a framework that helps you do that. And the first thing, for example, say you choose Java, you bring Java into your application. You start by deciding which objects need to be managed by the framework. You do that, and then you just bring everything in the Spring context. You bring the Spring capabilities one by one into your application, and then step by step you then implement it, like try to pull out functionalities, responsibilities from the system into small Spring Boot applications, and then split them into microservices if you'd like to do that. But that's the first step, is finding a good framework that helps you do that. And honestly, the best framework I found up to now that really helps you easy do that and offer you all the capabilities you need is Spring.
Sure. So from the little bit of knowledge that I've gained through the last sort of 20 minutes or so that we've been chatting about Spring. What you've said is that it brings a lot of mechanisms to Java. Let's say we'll stick with Java. Now, other technologies and code bases already have some of these things out of the box, such as dependency injection, data access, and things like that. Is there any known reason why those capabilities aren't in basic Java, and you need to turn to something like Spring for that?
Yes, that's actually a very interesting question. So yes, Java offers you as a language a lot of features, but it doesn't offer you, for example, dependency injection out of the box, which is an implementation over the inversion of control principle. It somehow offers you by that the capability to use it to leverage the Java capabilities more broadly. So if you want to implement an application that uses, for example, inversion of control, dependency injection, that's an implementation of the inversion of control principle, or aspect-oriented programming, then you indeed have to rely on some dependencies, and sometimes you have multiple choices. So you can choose from multiple places that offer you multiple implementations that offer you the same thing. Yeah. Now I would say by this Java actually offers more possibilities, because offer the possibility to more people implement, more communities implement their own features and then compete. Is like having a monopoly. If you'd implement by the language itself the feature, you force everyone use that feature. But when you don't necessarily implement it but just help in implementing it, you offer multiple communities the possibility to compete on implementing the same feature, and then of course the best solution wins. So that's one of the things I actually like about open source in general, allowing the possibility to multiple implement the same feature, and then the best will of course win, because the best will be chosen by most of the users, and will implement it and will develop it further.
Sure. So if I was to build a Spring application, Spring gives me inversion of control, dependency injection capabilities. But say I don't particularly like the way that it does it, for whatever reason, whether that's a sound reason, it's an opinion-based reason, or I'm just being argumentative, and I wanted to implement my own inversion of control, or I wanted to bring in a different dependency injection provider. Could I do that? Or really, when I'm building a Spring application, am I married to using the packages from Spring?
Spring is developed to be modular, which means that most of its capabilities you don't even need to bring them into your app if you don't need them. So say you implement an app with Spring. Nowadays we use some build tools like Maven or Gradle, and when you use Spring you can decide to only use its context, for example, for the dependency injection capabilities. And then if you'd like to add some aspect capabilities as well, aspecting capabilities, then you add another dependency to your POM.xml file. If you want to use transactionability, data sources, security, and so on, you have to bring more dependencies into your POM.xml and so on and so forth. But you are not forced to do that, so you can actually use only what you need. Now, if you go at the very low level of implementing, as you've said, your own dependency injection, then in this case, well, it's actually Spring is its foundation is the context, which also leverages the dependency injection. So in this case, you cannot actually implement your own dependency injection, even though Spring theoretically starting with one of the most recent versions, 5.2, if I correctly remember, is offering you the possibility to programmatically register beans into its context. I would say that if you go at the very low level functionalities as the context or dependency injection, if you want to do them by yourself, then you don't use Spring. So you can replace parts of the functionalities. For example, you can decide to use some kind of different mechanism for logging. You can even use Spring but decide to use some kind of your own transactionability that you implement by your own aspects. You can decide the same to use some your own implementation of security. That's something you can do. It's more high level. But if you go very low level, like for the dependency injection, that's actually the foundation of Spring. So I wouldn't say you can actually use Spring but implement your own dependency injection. Then you already, if you go that low level, you already start by implementing your own framework.
Yeah, yeah. So, as I previously mentioned, I've not really done a lot of Java, and the Java that I did was probably 12, 13 years ago, if not longer than that. And it wasn't in a professional capacity. Now, when I think of writing Java applications, I often think of Java applet games or server-side programs or desktop applications. I have written a bit of JSP in the past as well, which was Java server pages, which enabled me to write Java and produce a website. Now, I don't know if you can build a website in Java without something like JSP, but Spring has something I believe allows you to make websites called Spring MVC. Are you able to talk to us about that? Explain what that is?
Yes, so Spring MVC is quite old actually in Java itself as an implementation of that design pattern that we call model view controller. And firstly, it was used to leverage some web pages. So you simply get the request, the HTTP request, and then it's processed by a controller. Some action is triggered, and then the action actually leverages some HTTP response. Nowadays, we use the same implementation of Spring MVC, but we actually use it more for implementing REST endpoints. And you have this kind of decoupled architecture where you have a front end usually developed with a framework over JavaScript like Angular, Vue.js, React, and so on. And the backend simply exposes some REST endpoints that gets an HTTP request, gets the parameters, do some processing, maybe get or add some data into a database, and then returns, and you can secure them as well. So Spring MVC started with only producing the whole response that the browser would interpret in the end. And you would actually, first of all, even use JSP pages with Spring, because you mentioned about JSP. So you can actually write your own JSP pages, and then you allow them as being your view. They will be rendered at the end. They will be mixed with the details you want to mix from the controller, and then they will be interpreted by your browser once the HTTP response gets on the browser side. After that, you had some kind of templating engines. For example, Timeleaf is one of the most used nowadays. If you still use this approach where you get the request and you then just render all the response from the backend side. And then you have the newest approach. The newest approach is you don't anymore create the response completely from the backend. You just return the information, and then it will be processed by the front end itself. And the front end usually is designed by using a framework like Angular or React or Vue.js and so on and so forth. But all of these, they are still available with Spring, and you can still you will still find them out there in applications. I still find TimeLeaf. I still find JSP with Spring. Of course, I find JSP as well with Java EE applications and older applications. But now, being that we discuss about Spring, you find them with Spring. You find TimeLeaf, and you, of course, in the newer scenarios, you find the REST services and Angular or React apps consuming those REST services.
Sure. Yeah. So you can go out there and build it the same way that I tend to build websites myself. I write all the REST endpoints in .NET Core, and then pick up a JavaScript framework. React, Vue, Angular, or Svelte is one I've been playing with more recently, and we just had an episode on that as well. And then and build the front end there. So it's not the responsibility of any Java developer as such to go and build the front end. They can stick to what they like and what they know for the most part, and that's building back end stuff. So that's good.
It also helps a lot in the management of the teams in enterprise application teams, because you can separate your front end developers by your back end developers, and you can allow everybody to do what they know best.
Yep. Yeah. So I also mentioned as well that I always think about stuff being desktop run or on servers on-prem. Does Spring run in the cloud?
Yes, that's actually, I was thinking when you started with this question, I was thinking about desktop apps, and one thing I would like to mention is that Spring is not only about web apps. And that's something that I might have wanted to say from the very beginning, because it's something that I see a lot of people being confused about. Is Spring about writing web apps? Not necessarily. You can use Spring, and I have used Spring in desktop applications only, for example, for its dependency injection capabilities. So it's very easy to bring some dependency injection capabilities into your app only by using the Spring context, which is only a very, very small dependency you have to add to your POM XML. I have seen Spring used in testing applications. What are testing applications? They are apps implemented with Selenium, Gauge, Archelion, or different related frameworks that are used to create end-to-end tests for a bigger system. And I've seen developers creating this kind of separate apps, but using together with Archelion or Selenium or some other related framework, using Spring for its dependency injection or transactionability capabilities, the possibility to connect to a data source, and so on. So I don't want you to understand Spring like being a framework only used to develop web applications. You can use it in any kind of web applications like desktop apps. You can use it even in implementing end-to-end testing. And I've seen that, and I recommend that, because it really simplifies a lot of things, and it minimizes the syntax you might want to write. So take Spring as a tool that has a very, very large spectrum of applications you can use it with. Now, going to the cloud, Spring, of course, as any other framework, tried to go as much as possible with the trend. And of course, the trend is now having applications in the cloud and deploying microservices in containers, orchestrating them with Kubernetes or any other orchestration, Docker Swarm, and so on and so forth. And as you can see, Java itself first, if you take a look at the versions of Java, with Java 10, there have been added some implementations that help Java applications to benefit easier from being deployed into containers. Before Java 10, for example, you couldn't easily take the properties that were given when running an app that were given in related to the container itself. They were mostly related to the virtual machine on which the application was implemented. And starting with Java 10, you can actually take the processing power and the memory as part of the constraints that are set up for the container itself. And that's also for deployment in the cloud. And Spring itself, we have Spring Boot as a tool. So Spring Boot, what it does, it brings us configuration. It's that convention over configuration approach. You based on the dependencies that you add, it gives you some configuration out of the box, some defaults. You can override them, but most of them, maybe more than 90% of them, you will keep them as they are. And it brings you the possibility to create small footprint applications that have implementations out of the box which connect directly to your cloud. If you want, one of the most important things, one of the things that you never miss in an application, for example, that's deployed in the cloud, is allowing the cloud to be able to test your application, test if it's still alive. And then with Spring Boot, for example, you have the Spring Actuator. It already, you just add the dependency, it already adds you some endpoints out of the box that you can implement, you can combine with your Kubernetes orchestration tool or whatever you use to deploy your application in the cloud, and that will test your application to make sure it's still alive for aliveness or readiness. And so yes, Spring is actually one tool that you can use, and now it's very going into that direction. Use it to implement apps and especially microservices that run in the cloud.
Awesome. So it sounds like it provides a lot for every developer, for every
I'm sure
problem that there is. It seems like it's got some sort of solution or some way to help. So that's really, really good.
What I can say is that not the framework. So I have a really a very high respect for the community itself. So I don't see the framework as being the framework as much as I see the community behind the framework. So I think the community is the one that makes everything alive.
Sure. So we talk about a lot of different technologies, a lot of different programming languages, and the like on the Cynical Developer, and not everybody is a Java developer. If they wanted to move from another language and they wanted to spread the horizons a little bit, learn Java, would you advise those people to go and look at Java from the start and then move to Spring, or go to Spring first and learn Java as you pick Spring up?
So for sure, somebody wanting to learn Spring would first try to look at Java. So Java fundamentals, at least. You need to know how the very basics of the Java language work. Of course, Spring is compatible with Kotlin and is compatible with Groovy as well, for example, but it's still Java, the mother language that you'd first want to learn. And it's not the whole Java you need to know. You don't need to be an expert with Java first to go to Spring, but you need to know some foundations, like know the basics of the language, the operators. You need to know how to use collections, for example. You need to know how to use exceptions. And once you know a part of the very basics of Java, again, you don't need to be an expert with Java. You need to know at least a part of the fundamentals. Then you can start learning Spring. So what I recommend is start with learning the context of Spring, because that's what Spring knows. That what you put in the context of Spring is what you want Spring to know about your application. So first of all, learn how to tell Spring what you want it to manage out of your application, and then learn the dependency injection and how it controls your app. And then you can learn step by step any feature of that's any capability that Spring can offer you, and implement it in your app. It's like I always say I like very much to I like music very much, and I like to compare learning Spring, for example, or learning a language with learning how to play the guitar. You first learn how to play some notes and how to play the basic chords, and then you can play any song. If you get it the other way around, like a lot of people try to do, like for example just watching how to implement a feature on YouTube, it's like people just trying to learn to sing a song from YouTube. They just learn how to place their fingers on the neck of the guitar and then play it, but they don't necessarily understand what they are doing, and then they cannot play other songs. So when you start first with the chords, then you just can play any other song. If you start with a song, then you don't necessarily know to play others. That's how it works with Spring as well.
Sure. So if there are Java developers listening that think, oh, maybe I'll give this Spring a go, where would you point them for them to get started? Are there tutorials? Are there Pluralsight courses? Have you got a particular book that you would point them to?
So sure, there is a reason for why I started to write my second book that's called Spring Quickly. That book is what I see the first book any Java developer would need to get started with Spring. And I've started to write this book because I didn't see any similar resource for the moment. Of course, once you've, for example, completed the Spring Quickly and you know the very basics, and so you will basically by reading Spring Quickly, you will learn everything you need to know for the very beginning. You won't know all the details, but that's the whole reason. So if you take a look in the documentation of the framework, you will see. Maybe if you copy all that text out from there, you will find it's about 10,000 pages that you need to learn. But the whole idea is that you don't need to learn 10,000 pages of Spring to know how to use Spring. Spring is quite easy. The only problem is that you need a resource to teach you in the right order the very points you need for working with Spring in production. And that's what I try to do with Spring Quickly. So Spring Quickly, the second book I write, is the book I think any developer, any Java developer with the very basics of Java can read and learn the very basics of Spring. Of course, once you've read Spring Quickly, you are not an expert in Spring. You can be an expert in a technology by reading a book. It would be very nice to be so. But you have other resources out there, and I would recommend any developer, for example, after Spring Quickly, to read Spring in Action. That's a really, really good book. I always enjoy read a new edition of Spring in Action by Craig Wells. And it's the first book I wrote, that's Spring Security in Action. At some point, you need to know how to secure your apps, so it's no way around it. Security is one of the most important software qualities, and you need to know that from the very beginning. You need to take that into consideration from the very beginning of writing your application. So if you want to be an advanced programmer, you need to take into consideration security, and then Spring Security in Action is the book to give you all the details you need and all the practical exercises you need to understand and to learn how to apply security to your application. I also recommend people reading articles, like articles on medium.com or articles on Bildung, and similar sites where you can find free content. But be very careful always with articles, and that's not necessarily with Spring, any kind of technology. It can be Python, it can be .NET, it can be AI. When you read an article, the article, first of all, it might be obsolete. So take that into consideration. I always find with Java, because that's what I search, because that's my expertise. I always find articles that are old, and sometimes they present the way you would implement a feature 10 years ago. For example, this week I was actually searching something about how to work with a file, and I was still finding dozens of articles on how to use Java IO file. And in Java now, we don't use Java IO file anymore. We use the NIO features with the paths, and files implementation, which are there since Java 7. But if you take a look and if you search, do that exercise yourself, search something about files with Java on the internet, you will find dozens of articles that are about topics which were good 15 years ago, but they are not necessarily what you would like to implement them now. So you always take into consideration this and search multiple options and find the best you need to use. Don't take the first article and take it for granted. That's really important.
Yeah, that's a really good nugget of wisdom there that can be applied to any technology and any bit of research that you're doing online. Don't take the first result. Get a few results. Find the matching pieces and the most recent scientifically backed up information and go with that. But that I think wraps it up for today. That's all we've got time for. So thank you, Laurentiu, for coming on and chatting. It's been really informative, and I think I've learned quite a bit about the this little corner of the Java ecosystem.
Thank you very much for welcoming me here.
Yeah, not a problem, and all the best for your new book. And thank you to everyone out there for listening to The Cynical Developer. I'm James Stoddart, and you've been listening to Laurentiu Spilca talking about Spring. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help The Cynical Developer to reach more developers around the globe.